Station, this is Houston. Are you ready for the event?
Houston, this is the International Space Station. We are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Houston ACR station has you loud and clear.
Hi, I'm Charlie Precourt, former Space Shuttle Commander and the Vice Chairman of the Experimental Aircraft Association. Today, the crew aboard the International Space Station will be answering questions from EAA Young Eagles discovering flight through our Ray Aviation scholarships. This should be a lot of fun. Let's hear what questions our next generation of aviators has for Bob and Doug.
Hi, my name is Andrew Elliott with EAA Chapter 468 out of Williamson, Georgia. How does the workload during launch and flight of the new SpaceX Crew capsule compare to the same stages of flight aboard the Space Shuttle with the incorporation of newer technologies such as touchscreens?
That's a great question, Andrew. And really the big benefit of a new vehicle like the Dragon SpaceX capsule is the amount of automation that's been put on board. Many of the systems that we monitored manually with the Space Shuttle or previous spacecraft have been replaced with automation to allow us to have a much bigger picture view as we operate the spacecraft on its way to the International Space Station.
Hi, my name is Shannon Daly from EAA Chapter 279 in Hanson, Massachusetts. Since you have a lot of experience in space, I'm curious to know, is it difficult to adjust back and forth between 1G and 0G?
Now that's an interesting question. We've each gotten to fly twice on space shuttle missions, and those missions were approximately 2 weeks long. And I think we both felt that adjusting to and from 0G, our bodies adapted fairly quickly. This mission for both of us is going to be a little bit different, as we've been aboard Space Station for over a month and a half now. So our body has probably completely adjusted to 0G. So the thinking is that we will likely have a longer process to readapt to 1G back on Earth. And typical of a longer duration cruise, we'll have a rehabilitation program with our strength and conditioning specialists when we get back, and that's a 30 to 45 day process, and hopefully gets us right back in shape where we were before we left. Great question.
Ryan Harris from EAA Chapter 485 in Pensacola, Florida. On behalf of my local EAA chapter and Civil Air Patrol Squadron, we would like to know what roadblocks you have faced during your career and how you have pushed through them while staying motivated.
That's a great question. I think one of the things that both Doug and I faced from a challenges perspective was figuring out a way to even pay for college. And so luckily enough for us, we were able to pursue ROTC scholarships and find a way to take that initial step in our education. And so I would, there are challenges out there, but there are ways to overcome them.
Hi, my name is Reagan Buzzard from EAA Chapter 524 in Frederick, Maryland. I'm an incoming freshman and ROTC cadet at Embry-Riddle Aeronautical University, Daytona Beach, where I am majoring in aerospace engineering. I recently obtained my pilot pilot certificate and am interested in becoming an astronaut. What recommendations do you have for a student at the beginning of their college career to help guide them towards their ultimate goal of doing what you currently do for a living?
Wow, that's a great question, and I'm sure there are a bunch of different answers. But I think what I would recommend is, the first thing is just excellence in everything that you do. So starting off your college career, probably your biggest goal should be to learn a lot about your field. Aeronautical engineering sounds like a great place to start out with if you're pursuing a career as an astronaut, and then do very well at it. And hopefully you have a passion for it as well. I think that goes so far in achieving excellence in a field, is if you're passionate about it and you enjoy it almost beyond anything else, that just makes that work so much easier to do. And so I would just say, study hard, work hard, and best of luck to you.
Hi, my name is Jordal Leroy Bruce from EAA Chapter 1027 in Willits, California. We all know that this is a tremendous step forward in space exploration. Where do you see yourselves in the future of U.S. space exploration?
It's a really interesting question for both Doug and I as to what we would see ourselves doing in the future. I think if you had asked us when we were students at the military test pilot schools that we went through what our dream job would have been, it would have been developing a new spacecraft that we were eventually going to fly on. And we, luckily enough, got to follow that dream and achieve it. And I think our goal next is to do the same thing again. So hopefully the opportunity will present itself for us to continue to develop new spacecraft that will, make their way into low Earth orbit and beyond.
Hi, my name is Alexander Strickland from EAA Chapter 1254 in Camdenton, Missouri. Within the past year, I suffered a major knee injury, and throughout the recovery process, my quad and calf muscles experienced muscle atrophy due to not using them. So my question is, in space, how do you keep the same thing from happening to you and your muscle systems?
Wow, awesome question. We exercise every day in space. So we do aerobic exercise either with a similar to an exercise bicycle, or we have a treadmill. And then we do resistance exercise with what we call ARED, which is Advanced Resistive Exercise Device, a NASA acronym. But essentially, it allows us to lift weights in space and provides resistance, and so we can keep our muscles developed as we work through several weeks and months in space. As you said, it's very easy to atrophy because you have no gravity pulling on your body. You don't use your legs pretty much at all during the day. You use your arms to translate. And so it's a great way to keep yourself in a good shape. And we've seen over the years, especially on the space station program, the last 20 years, where astronauts have come back in some cases in better physical shape than when they left the planet, because you're exercising every day. So that's what we do. The machines that we have take a fair amount of maintenance, and they're fairly large. So as we develop new technologies, we're going to have to figure out ways to make these devices smaller as we venture out into the solar system.
Hi, my name is Sophia Haig from EAA Chapter 179 in Albuquerque, NM. After going to space multiple times, is there any advice you would give your younger self prior to your first flight?
The kind of advice that we would give ourselves is much the same advice that we would give any other folks who are pursuing their first flight. And it's usually along the lines of make sure that you take a few minutes to enjoy it. While there are plenty of things to do while you're in space, there are plenty of things to focus on to make sure that you get them exactly perfect so that you can get a future mission. It's important to enjoy yourself, and it's important to take some mental images so that you can share that experience with students or coworkers or the rest of the country and the world when you come back. And if you don't take those moments to do it, the space flight will go by in a blink of an eye, and in some sense you'll have missed a big part of the mission, which is sharing it with everyone else.
Hi, my name is Matthew Shaw from EAA Chapter 770 in Springfield, Illinois. Glass cockpits and automation have been a major improvement in aviation as well as spaceflight. In your opinion, how big of an improvement is the Crew Dragon's displays over the space shuttle systems as well as the jets you flew during your military and NASA careers?
Yeah, great question, and I talk about it a lot. The shuttle, developed in the 1970s, was 2,000 switches and circuit breakers with steam gauges, essentially. There were various upgrades over the years, but it essentially didn't change too much in the big scheme of things as far as situational awareness for the crew. And it was very intensive for the crew to fly and operate. So there was multiple people on the flight deck in order to successfully execute the mission. With some of the fifth-generation fighters that both Bob and I have worked on and flown, the F-18, the F-22, it was more of a glass cockpit, heads-up display, very much intuitive for the operator or the pilot, and was much easier to fly, essentially, because of all the situational awareness that the displays brought to you. Crew Dragon is very similar, very intuitive displays. They're touchscreen displays. Everything you need to know is on those displays, or either the display right in front of you or the display in between Bob and I. So it's a tremendous leap in situational awareness, and what that allows you to do is monitor the vehicle much better than you would during our time in shuttle, where it took just too much brain power to fly sometimes, and you needed backup capability with another crew member.
Hi, my name is Carter Allen from EAA Chapter 186 in Manassas, Virginia. How do you anticipate re-entry varying from your prior missions, and do you think that in the future there will be support for a direct landing, like the booster rockets, instead of a splashdown?
Well, thanks, Carter. One of the things that we expect to see, of course, coming back in a capsule versus the space shuttle is a lot higher G loading as we come back through the atmosphere. So Space Shuttle was a relatively gentle return to Earth, specifically designed partially because the vehicle really couldn't handle substantial loads with the wings and the size of the structure. The capsule is quite a bit smaller and, of course, requires quite a bit heavier loading in order to come back through the atmosphere and remain, landing at the appropriate location. I certainly believe that we'll have the capability in the future to do a very pinpoint and precise landing back on the ground, maybe right back at the more like a helicopter pad landing with the spacecraft. The challenge is coming up with the right amount of redundancy for a system like that and having it in place, and so that one of the things that a parachute system really provides is that altitude, as the drogue chutes come out, as the main chutes come out, you have a little bit more time to anticipate what the down modes need to be from a redundancy perspective. If you're trying to put all of your eggs in that final fraction of a second before touchdown to get those thrusters on and get stopped, it's really challenging to manage that problem. Someday folks will solve it. We're just not quite there yet with the level of redundancy we'd like to have in place for human spaceflight.
Hi, my name is Addison Gear from EAA Chapter 897 in Juneau, Wisconsin. What is something you wish someone had told you when you were just beginning your aviation and space career?
Wow, great question. I think for me, I wish maybe I had had a little bit more advice on just what it was going to be like going into the military. I came from a family that had really no experience in the military before, and so it was kind of one of those things where I just had to jump in head first and hope for the best, and it ended up being just a great fit for me. But going from a idyllic civilian life and jumping right into the military is a little bit of a transition, and it was a challenge at first, but I think frankly everything else is just, it turned out great, and I really enjoyed my time in the Marine Corps and in aviation. Just a tremendous enjoyable experience.
Hi, my name is Brandon Slater from EAA Chapter 902 in Milano, Oregon. What kind of systems do you have to monitor on the Crew Dragon while in orbit, and what checklist did you go through before docking with the ISS?
We often get asked questions about the automation or the improvements that are out there. And really, we have to step back and think some about what our primary role is, which is monitoring for things to go right, just in case they don't. And so primarily the review that Doug and I performed as we approached the International Space Station was focused on problems maybe with that automation, which would cause us to not continue with the docking, maybe back away from the International Space Station, or in some cases actually choose to fly all the way out of that approach corridor and come back in either a different orbit or even a different day later. And so we reviewed those procedures in case we needed to follow them.
Hi, my name is Tyler Pearson from Vintage Chapter 25 in Sacramento, California. Many young people, including myself, have been inspired by your recent launch, which made history. What advice would you give to anyone pursuing a similar career path?
It's a great question, Tyler. I think the first thing is find something that you love to do. Obviously, if it's a career like Bob and I have pursued, science, technology, engineering, and math is a great field, you know, some of those choices, and then do it well. The other thing to remember is an education, a long education, 4-year degree, and then typically most astronauts go to some sort of a postgraduate education as well. Do very well at what you pick for majors, and then understand that most astronauts, this is at least our second or third career by the time we get here. So building that experience in your field is a great thing in order to be selected as an astronaut, and usually is a must. So those kinds of things are the things to think about, but just remember, just do well at everything you do and be passionate about what you do.
Hi, my name is William McCarthy from EAA Chapter 534 in Leesburg, Florida. What's your favorite place and time to look out the window at the International Space Station?
Well, I think there's kind of two answers to that question. For those of us who've had a chance to do a spacewalk, I think the favorite place for us on the International Space Station to spend time is outside looking at the Earth below us, and that's a wonderful place to do it. Of course, we don't do spacewalks every day, and not everybody is lucky enough to have that opportunity. We do have a windowed section on the bottom of the International Space Station called the cupola. It was actually delivered to the station by a shuttle flight that I was on, STS-130, and then we were able to go outside and do a spacewalk to open up those windows for the first time, which was really cool. That's definitely our favorite place, of course, if you can't be outside.
On behalf of EAA, a big thank you to my colleagues at NASA for providing this wonderful opportunity to our Ray Aviation scholars. If you'd like to learn more about our EAA and our programs for young people, come visit us at eaa.org.
Station, this is Houston ACR. That concludes our event.
Thank you to all the participants. Station, we are now resuming operational audio communications.